Hi, welcome back. Today we're going to take a look at exercise 15 in Creo Parametric 6.0. We're also going to use a product called Mastercam because today what we want to look at, being that this is an advanced class, is how to not only build a part inside Creo, but then take it and bring it into some sort of manufacturing, or what they call a CAM package for computer-aided manufacturing. Now Creo has its own manufacturing module. Unfortunately, I don't have access to that, which I thought I did, but it's I guess not. So what we're going to use is Mastercam, and that's what we use at our community college anyhow. So that's fine. And Mastercam is a very commonly used CAM software. Once you understand how one works, you can pretty much figure out the others. So without further ado, first of all, we're going to have to download the software. So what you're going to do is just type in Mastercam HLE and click on Mastercam software, download your demo today. It's going to ask you for some information, an email address. Use your student email address for this, okay? And you should be able to download it for free. Okay, once you get it installed, we're not going to hit it right away, but I just want to show you, we're going to build this model that you see right here. And this is actually, those squiggly lines are what they call the toolpath. We're going to see how that works inside the software, and then we're actually able to simulate what it does. So like, for example, here you can see all the different paths I've set up. Like, we're going to set up a roughing finish to cut out that material with an end mill, these 3 pockets here, and then we're going to put in a finishing cut, which is a smoother transition, and then we're going to put some drilling operations and maybe even a reamer cycle through. But let's take a look at this. I'll hit play. Let me just start over here. And here you could see it's simulating the CNC machine cutting out the material. You can see the end mill there. It also gives us the time it takes for these procedures. So we're looking at here about 37 minutes, which all that can be adjusted. Depending upon the tooling you're using, there's settings inside here that you can set up. Now take a look there. See, look at this. It's rough right now, but watch, it's going to go through and do its finishing cut. And there, see how it smoothed it out? Oh, and then what you missed there at the end, it actually put the little drilling cycle. So here, let's just go back so you can see that. So and see, there's the 2 drilling cycles. Okay, so let's see how that works. First of all, well, actually, let's build our model inside Creo. Now the drawing that you see here, I haven't put it inside the training guide as of yet. So just be aware we don't have that up. Okay, let me find my drawing that I had. Okay. My apologies, I accidentally closed it. Okay, here we go. All right, so this drawing I plan on getting in the book, but if not, just do a screen capture of that and you'll have it ready for you. So it's just it's like a fixture. It's a cheap little fixture we're putting together of 1060 aluminum. It's a 4x4 block, and it's the 1 inch thick. It has 3 pockets here, a triangular pocket, and it has a rectangular, I should say square, and then it has this circle pocket. Then it has 2 holes that go 3/4 of an inch deep. So don't try and put them all in at once. Those holes we'll use the hole wizard to put in. Okay, let's begin. Start a new part inside Creo. So make sure part's selected. And go ahead and label this E15. And let's go ahead and select the front plane and go to extrude. Now find we'll go with corner rectangle. Drag out your rectangle, middle click 2 times, and pull these out. Let's go ahead and make this 4. Drag those in a little closer if you want, by 4. And you can hit the refit button. All right. Now what we're going to do is we're going to go ahead and we're going to extrude this. So don't try and put all those features in at once because none of them are through. Okay. So we could go to OK, go to Model, and oh, actually just go to Sketch. We already went to Extrude, so just hit OK, and make it 1 inch. And if you want, rotate it a little bit so you can see it. Hit the green check. Select this front face, go to Extrude again, and we're going to go ahead and put in a rectangular pocket right there. Middle click. Let's go to the circle tool, a nice circle right here, middle click, and let's put some dimensions in on here. So like here we have this dimension. Let's go ahead and put that in as 0.5, and actually let's verify that drawing again. Everything's a ½ inch off of the edges for the most part. So that's 0.5. Oops, I put that away too quickly there. Let me move this over to my second screen so I don't have to toggle between. All right, and so this one's going to be 1.5. And then this is 1.5. And then we put a dimension between this point and that edge. Middle click over here to drop the dimension. That'll be 0.5. Middle click 2 times. And let's lay this out so it looks pretty decent. Let's drag that up there. Okay. And the diameter of this, let's drag that out. That's going to be 1 inch. And then it's located off that bottom edge, 0.75. Now let's go to dimension and dimension the center point of that hole to this edge, and then middle click down here, 1.125. Middle click, let's lay the dimensions out a little bit nicer. All right, so we've got those positioned. Let's go ahead now with the triangle. So go to the line tool and align yourself over here. Now you can't really align it really well, but just go ahead and get close to it. Click here, drag this really far down and make that triangle. You're wondering like, hey, it doesn't look like that just yet. Well, watch. What we have actually, we have theoretical sharp corners on the drawing. So the bottom corner here to the bottom edge, just drop it right there, is going to be 0.941. And that's the theoretical sharp corner, because it's going to be theoretical in a minute once we put the radius on. All right, then this dimension here is going to be 0.5. And now what we want next is another dimension from this point here to this edge. Middle click right here, and that's going to be 1.78. And finally, let's use a collinear. Let's see here. Let's do coincident between this line and this line here. Okay, middle click a couple times to get out of the dimensioning tool. Looking pretty good here. All right, now we could put the sketch fillets in. So sketch fillets, they're 0.25. So if you go over here to the Fillet Tool, and we'll go right, we'll use this circular. Click here and here, there and there, and here, there, and this corner that one, this one here to that one, and from here to here. Okay, now what we can do is just make one of them 0.25, and now select equal, select that arc to this bottom arc, and select that arc to this arc over here. Select that arc to this. And you could probably select the closer ones too, because they're all going to be the same. And notice the dimensions disappear. Now we still do have to fix some of these dimensions because it turned those weak, but that's okay. We'll go ahead and put those in next here. So we see this one right here. Let's right click on it. Actually, if you just click on it, you should get lock. Go ahead and lock that and hit enter. All right, we'll move this one over here, and this one needs to be that 1.5. It got moved a little bit, 1.5. And then this one here, 1.5. And this here, 0.5. And it's going to make us put those dimensions in again. Let's see. So yeah, let's go to dimensions, select that vertex there to here, middle click. I guess we could have done this later. This one is going to be 0.941. Okay, and then from this point here to this, and that will be 1.78. Yeah, we probably should have just waited to add some of those dimensions so we had these straightened out. And I believe we've got everything. Let's see, for those three. Just double check, make sure it all goes together nicely. At the 0.5, 2. All right, I think we're in good shape. We could have actually dimensioned to those points. I have that on the print too, versus the theoretical sharp corners. It's really up to you, but we're good. All right, now what we're going to do is we're going to hit OK, and we're going to flip those so it's going to cut, but the depth of those are only 0.5. Hit the green check. All right, now for the drill holes. Now what we're going to do is use the hole tool. So select the hole tool, and we're going with standard hole. And with the size here, we're not looking for a screw size. Actually, just go to simple, standard there, my mistake. We don't want the actual screw thing in there. Okay, and the diameter, we're going to put in 0.5. And the depth is going to be 0.75. I'm going to click on placement here, and let's go ahead and select this face. And now what we can do is drag this to this edge. And that first one is going to be 0.75. Okay, and then this to this edge, 0.75. And now we have our hole located. Okay, let's see. Let's go ahead and hit the green check. So we have the 1/2 inch. Let's add another hole. Go back to hole. This time set it to 1/4 inch and 0.75 deep. Go to placement. Oh, make sure you click on standard because we want the drill tip in there for this. Okay, so go to standard, and that means it's going to put in a 118-degree drill tip for us. Select this face here. Same thing, drag that to this edge. Oh, try that again. Okay, it's on the edge, that's good. Drag this to this edge. Let's change those up. So this one is 1.25, and this one is 1.375. All right, hit OK. And you can actually see the cones at the tip. All right, so our part is done and it's ready to send out. So let's save it and just save it. I'm going to save it to my desktop. It's E15. All right, now we should be able to go right into Mastercam. So if you have Mastercam, find the Mastercam tool, or after you've downloaded it, and it's alphabetic. So if you find it here, Mastercam, click on that, get it started. I'm going to bring mine up here, and actually I'm going to close mine out. Oops. Let's get rid of that one. So I'll restart Mastercam. Okay, now we should be able to go to open, and I remember I dropped it on my desktop, and instead of all Mastercam files, look for Creo. There it is, E15. Hit open, and there we have it. Okay, so you can see how easy it is to transfer that in. Now let's see about making our toolpath. So the first thing you have to do when you get into a package usually is you have to select the machine. Now, just like you select a printer, and printers all have different names, different drivers, so do machines. And the drivers for the machines are called posts, basically. And what they do, most machines work off of Fanuc, which is a language for machining that was developed years ago, okay? And there's just subsets of that. And there's also other languages too out there, but the most common is probably Fanuc. Now, let's go to machine here. And you'll see there's mill, lathe, wire, router. Hit the little arrow under mill, and you'll see there's default and managed list. Managed lists used to provide several different posts in there. There's only like one or two, none of which we want to use for our machines. But usually wherever you're going to school at, especially if you're going to ECC, we have multiple Haas machines. We already have the posts loaded for you. So you would actually go to managed list, or you would actually see it underneath default. But by going with default, it's going to automatically output the native Fanuc code, all right? Which the only variations is just sometimes like with just how they have. It's just like any programming language, or even just language in and of itself. Like English and Spanish are subsets of the Latin language, and so there's some variation there. They don't always sound the same, and sometimes they do. So that's just how they wrote the code. So these posts help translate it to whatever machine you're using. So usually you could get the posts free from either the vendor or maybe Mastercam. There are posts that cost money, and sometimes they can be very expensive depending upon the machine that you have and how rare it is. It's my understanding you could also write your own post too, and I had a former professor that wrote his own post at one time. Pretty impressive. Anyway, we're going to go with default. Okay, so now hit the little plus symbol next to properties and find stock setup. And what we're going to do in stock setup, notice here it's wanting us to identify the material that we're going to start off with. So usually what you see with CNC machining, and actually here I'll show you a little picture here. Go to YouTube, and we go to CNC, and you can see an actual CNC in action here. And I could only play it very quick lecture. And you see it just milling around that part, and it's just cutting off material. Okay, so that's what we're looking at. We start off with the block, and let's see, do they show the block starting off here? There it is. See, that's the block, as you can see. And it gets chiseled down. So it's, instead of additive manufacturing, which many of you might have heard of before, that's 3D printing. This is subtractive manufacturing. It uses what's called like end mills and cutters, a variety of different colors, and drills to make this part. So we have to program it as such. All right, so right here we could put in the size of the block that we got, but let's imagine it's already milled down to size. And so we're going to just hit all solids here, and it will pick up the parameters of our block, 4x4x10, or 1. And so we're in good shape there that it automatically identified that. If we wanted to, we could add a little material if we wanted to face it or something like that too. This is just very basics I'm showing you. We're not going to get into facing and stuff like that. Okay, now if you go to tool settings, you can have feed calculations done inside the software. And typically the feed calculations inside Mastercam are pretty conservative when I've talked to people out in industry, i.e. everything is about production and speed. So, and also depending upon the tools you have, you could bump up the speeds and make it go faster, depending upon the lubricants. There's a lot of different factors, the material type, and that's what we're here for, is to help us go through that. And so instead of aluminum, let's go to select. And here we could actually pick out a material and have it go by the material actually by checking from material. We'll do that in a second. And instead of mill current, go to mill library. And here you can see, actually we'll go with 6061. Now 6061 is a tougher material than typical like a 1060, which I think, yeah, I actually have it set 1060. 1060 is very soft aluminum. 6061 is more of an aircraft aluminum. And you could look that up, Google it, see how strong that is over 1061 or 1060. All right, hit the green check, and that will adjust the speed. So like if something's really hard, it's going to slow it down, that cutter. Because if it's cutting too fast, it'll do a couple things. It can burn the tool or break the tool. And tools are expensive, so you don't want that. But you want to find that balance because you don't want it to go too slow, because time is money. And when you're working in manufacturing, you want to find that nice balance. Okay, so always talk to your manager until you get more experience on what your feeds and speeds should be. But we're going to go for material and just hit the green check. All right, now you'll notice here we have 2D, 3D, and multi-axis. Now we have, at the college I work at, we have up to a 7-axis machine. We have multiple 3D machines, which are Haas, tool room mills, TM1s, I believe they're called. And one of them has a trunnion, which is capable of 4 and 5 axis. So normally we're capable of 3 axis with ours, but we have some that are capable of 5. And then we also have, like I said, we have a 7-axis machine we just got in recently. But this would be for those 4, 5, and 6 or 7 axes machines. Okay. That's more complex. We're not going to touch that today, and we're not going to get anywhere close to it. In fact, even 3D, you might think, well, that's a 3D part. It is 3D, but technically, for what we need, we could go with 2D, and it's just a level of simplification. 3Ds usually indicate you could put in pockets and things with more curvature. We don't need that. These are flat pockets. So you'll see if you hit the arrow here, there's different strategies, and strategies are great because you could, depend upon the material type, you could cut down on time, on how long it's going to take. You saw earlier there was that process was 37 minutes. There's guys out there that could shrink that down with the proper tools and with proper settings, feeds and speeds, makes a big difference. But you'll see there's pocket and there's dynamic mill. Now, on more modern machines, dynamic mill is really amazing stuff. It actually, what it does, it's tool engagement that occurs. It's something that Mastercam has, and other systems I'm sure have something similar to it. Maybe not all of them, but it enables like tool engagement that optimizes how it's going to cut something. And it doesn't just cut zigzag. There's no stopping like that. It's high speed, so it's constant. It's a flowing contour. And also, the algorithm that's written in there can vary, like when you're cutting. Like sometimes it might cut 20 thousandths, sometimes it's going to cut up to 200 thousandths, depending upon the algorithm. And it's really pretty amazing when it's capable of. So we're actually going to use that, even though it's not necessary for this one. But I just want to show you. So let's go with dynamic. All right. Now click up here for machining regions and select these 3 bottom surfaces. Just those bottom surfaces. Do not select the drills. The drills are going to be a different operation altogether. Okay, so we selected those 2. And those 3, they should turn yellow like that. Hit the green check and hit this green check here. Now here's, again, different strategies. We're set to dynamic mill. Let's go ahead and pick a tool. Now, hardly ever want to use the default tool that's in there. It's not, there's no brain picking that out. There's no AI there, okay, that's picking out in this tool. There is AI built into this Mastercam, but we're not looking at that right now. So let's go to Select Library Tool. And if we go to Filter, we are looking for, oh, it was already set for us. Hit None, and then just go to End Mill Flat. All right. Notice there's bowl, there's rounded, sphere. There's a whole bunch of tools. Now, be aware, your machine may not have all these tools on here. These are just options that you can customize. So hit the green check. And now what we're looking for is we're going to go ahead. These radiuses, remember they're 1/4 inch. Let's start with a 1/4 inch diameter. All right, not a radius. 1/4 inch flat end mill. Hit OK. All right, now you'll see there's the tool diameter and some information there. Feed rate pops up, spindle speed. So you could customize all that stuff though, but wait till you get more experience, okay? Now, let's go to holder, and this is where you could pick from a library of different holders. We're just going to go with the standard. Now, go to cut parameters. And here you can see how it approaches, step over, toolpath information. We could adjust this for the step over. Notice I have a percentage, and that step over can actually vary. It's really pretty cool, this algorithm they have. Now the stock to leave on walls, we can see it's set to 50. Let's go with 30 thousandths on that. This is going to be a roughing cut. It's just going to go in, and we want to cut out as much as we can, as fast as we can, and as efficiently without burning up the tool. All right, and we're not going to go into all these different details. Those of you who are going to ECC, the 220 class goes into more details with this type of thing. All right, so anyhow, we're going to go with, notice there's corner treatments. We're not going to really do much here. I don't want to go into all these depths just yet. All right, and there's linking parameters, planes. Let's just go to coolant, and let's turn on coolant. Coolant's always a good thing. Okay, if you run it without it, it could burn up the tool. You're able to go faster with coolant as well. And hit the green check, and you'll see, depending upon the speed of your computer, you'll get this to occur. Now you can see that's the entry motion there. It's swiveling down, going layers, and this is the path that it creates. So let's see what that does in the simulation tool. So go up here to select all operations, and then we didn't really have to hit that, by the way, but go to verify selected operations. Okay, now it's going to bring in the verification software here. Now be aware, in real world, sometimes you have multiple verification softwares. Like this is a good one here, but sometimes you want to double check. And what it does, it checks for gouging or unusual phenomena that might occur. And so you always want to verify it ahead of time. So let's just hit play here. And you can slow it down, like right here is the slow. And you can see it going in, making our cut. Now you can see how it's like very rounded. It's kind of fascinating how it does that. I'll speed it up a little bit. All right, so there we could see it was a rough cut. All right, and what I mean by rough, see all those little ribs or ridges that are in there? Let's smooth it out with another cut. This is typical. This is actually what you end up doing in real world. So we'll have what's called a finishing cut. That was a rough cut. Now we have a finishing cut. And there's actually tools for rough and finishing cuts that are more advanced. We're not using that here. We're not going in that type of depth. But now what we can do, go up to Toolpath Group, click on Dynamic again. It's going to drop a new one in. Let's do the same thing. And it's my understanding there is a way to reuse this, the selections, so you don't have to always make the same selections. I know in the wireframe mode there is, at least with lathe. I don't know about here though. Anyway, hit the green check once you got those. Hit the green check again. And now the toolpath type. Let's go to area mill. Now we're taking a different approach here. And you can see the strategy change. All right, it's more consistent now. Let's go to tool. And we could use the same tool. We could literally select it. Or we could go with something else. Let's go to select library tool. Let's go with the bigger tool that could get in there and smooth out some of this. So and sometimes you might want to go with a smaller tool. It really just depends on your strategy. Let's go with a 3/8 flat. Again, you could see the feed rates and such and make modifications. Any parameters here, like now we have cut parameters. Now for this, we want to go with just 0. We want no stock left over. See, watch this. It's going to take away that. So it's going all the way down to precisely what size it's supposed to be. All right. And normally once you do this, you don't have to go back and turn coolant on. It should remember like some of those settings from the previous setting. Now hit the green check. All right. Now let's go ahead and now this is where you want to hit select all operations. You could click at the very top too. That just makes sure it's going to play video for all of the operations. And now hit the verify. Okay, let's hit play, and it will start first with our first roughing cut that we had. Now we didn't have to do all. We could just done that one segment, but we'll just do it to see. Again, you can see that it's rough. Zoom up. You can actually rotate and see the roughness of the surface there. Now watch what happens when we get to the next, the 2D high speed area mill. Okay, did it not take in that second one? All right, maybe I made a mistake there. Did I pick the wrong? Let's just verify that one. I just want to see if oh, it only picked up on that one little area. That's odd. Okay, am I did I not select all three? Okay, I'm not entirely sure what happened there, but I think you guys get the idea. That I don't want to spend too much time on that for some weird reason. I thought I selected all three, but anyhow, you saw what it was supposed to look like earlier. Okay, so moving on to the drill, and so click on drill. Again, we're in the 2D. Select only one at a time. See, select this edge right here. You should get a little red cross at the base. Don't ever select the top edge unless that's your intent, because it's not going to go in. It's going to stop at that top edge. You'll see the little drill pointer, or the point of the drill, but it's not going to go full depth. So just be aware of that. Okay, now hit the green check, and we're going to go to Tool. Let's see there. We're set to drill. Tool, and let's go to select Library Tool. Go to Filter, hit None, and then let's go to Drill right up here. Click on Drill, hit the green check. And now we're looking for the 1/2" drill. So it's probably somewhere halfway down, past halfway. There it is, tool number 162 if you're looking for it. Hit the green check and hit the green check here. All right, there we could actually see. Oh, I went a little too fast there. Let's click on parameters again. Now go to cut parameters. Now what you want to do, let's go with this one and go with a peck drill. Now the typical drill is fine, but sometimes depending upon the material, when it's drilling, if any of you have ever drilled into metal with your, just a hand drill, sometimes you'll see a helical chip that's very extended. You might want a peck drill to break that. There's also, actually what's better, they even have the chip break. There you go. Okay, and that might spare your tool. If you're breaking a lot of tools, especially drills, think about adding that. It just changes the dynamic a bit. All right, let's hit the green check. Click on that, hit the green check to update it, and there we could actually see the tool. All right, now let's go ahead and get in here. So for this next one, we're going to pick drill again. Select that bottom edge. What's really nice in this latest version, you can select right through the top surface. Always make sure there's a little red cross in there. All right, you can see the diameter is 1/4 inch. Hit the green check. Tool, select Library Tool. It should remember from last time, and find 1/4 inch, which is like, I think 120 something. So 124. Tool 124 is 1/4 inch. Okay, and it should remember those settings. Oh, let's try and coolant. I should have turned that on earlier. I should go back, fix the other one too. But the cut parameters, it remembered chip break. Now the peck, maybe we could set that to 0.2. So it's not quite as common. Might speed things up a little bit. All right, so now that we have that, let's go ahead, hit the top, and let's hit verify. Hit play. Now it did clean that one up, so apparently it just, I should probably go back and fix that. And now it left the drill inside there. But So there we have it. Okay. Now to fix this, what we can do, we might be able to go back. We'll just leave it. Don't worry. Yours might have actually worked. I don't want to screw yours up if it's actually working fine. All right. So with that, now if we wanted to ream, you can actually go in here. Notice they have like thread mill. They have a lot of really nice features. But we'll just go back to drill. And let's say we just wanted to ream this one out. So again, select that bottom edge, hit the green check. And for the tool, let's see, wondering if advanced drill might have a ream function. I'm not sure. You could look that one up though. But we'll stick with the standard. Go to tool, select library tool, filter, and hit none, but then find reamer. And notice this too, for the tool material, all the different materials you could select between these, like HSS, high-speed steel, that's like your common drill. Carbide, much stronger, higher carbon concentration. Typical high-speed steel might have like maximum 2% carbon content. Higher carbon is going to give you a harder tool. Carbide is above that, like 4%. And then there's ceramics, which are great because they don't have the heat issues and things like that. Titanium nitride coatings, those are the gold coatings that you sometimes see. There's even zirconia, which is a blue coating, and those help prolong tool life. Okay, so anyhow, let's hit the green check, and we'll go with a 1/2-inch reamer, and hit the green check. All right, one last simulation. Let's go back to simulation here. Oh, it was just that one reaming procedure. I didn't select the whole thing, so let's go back up here. That's why it's important to hit this button here. And then now we can hit play, and I'll speed it up so it goes through pretty quick. Okay, now what you do at this point when you want this to output, right here is the G1 post-selected operations. Unfortunately, on the HLE edition, you can't output this post, or you can't output this code for your CNC. You can, however, save the model. Those of you who are in my class, if you'd like, you could come in and you could bring this model, or this save this Mastercam file, bring it in, we could output the code on one of our workstations. Now, with that being said, what it looks like when you're done, let me see if I can find some of the code here once it's output. This is what it looks like. So you'll see it actually outputs the code with some information here, and a lot of X and Y and Z code. That's how it's moving throughout this process. Okay. And that's what you feed into the CNC machine. And then it cuts that part out. That concludes this exercise.